Microsection is extremely important in the laboratory analysis of both printed circuit boards and printed circuit board assemblies. We do this by actually taking a cut or a chunk out of the PCB. It's mounted in an acrylic resin, and then that resin is then cured. This resulting puck is then polished using diamond grit of different consistency until we have a very, very precise surface that we can measure. This is put under a video microscope that has the ability to measure those and tell us what's happening. Not only how the surface wets with this solderability testing, but at the same time we can measure the thickness of the copper, and we can also look for any of the imperfections that may occur in the barrel of the hole. So this one test allows us to perform a series of measurements. The IPC has defined 42 different defects that we can see in this one microsection. This is an extremely important part of how you evaluate the interior of a printed circuit board and also how you evaluate the quality of a solder connection. Testing is important on the bare board side because what this is intended to do is to A, look for opens and shorts. In other words, are there any broken traces and are any of these traces shorted? But it also is a final check because during the fabrication process, it is entirely possible that small changes could be made to the artwork. Consequently, the bare board test, if it is performed to the original designer's net list, this file is called an IPC D as in David -356 file. We load this file and then we run a test to see if the finished PCB precisely matches the original designer's net list. This allows us to close the loop. The device takes a series of probes and it then acts much like 4 technicians moving at incredible speed to make measurements using a multimeter. And this device shown is a typical flying probe bare board tester. Solderability of a printed circuit board is extremely important. That's the whole purpose. One of the simple measurements for this solderability is to take a section from the PCB, carefully float it on a molten pool of solder, remove that quickly, and then perform a microsection to look at the wetting of that surface. The microsection shows the solder has properly wet the surface. It is wet up through the center of the hole of the PCB and flowed across the top. This particular PCB wet very, very nicely, and we know that when this is sent to the assembly process, it will perform very, very well. DSC is an acronym. They stand for Differential Scanning Calorimeter. What this device does, it is a thermoelectric measurement of the plastic that is in the printed circuit board. In other words, it tells us the melt point. People call this the glass transition temperature, or big capital T and small sub g. This melt point is very critical in the assembly because it determines the point at which during the assembly process the laminate starts to become plastic, at which time the thermal expansion becomes exponential. Therefore, different laminates are purchased with different glass transition temperatures. The device shown on the right measures this particular characteristic. You will notice that a very small sample of the PCB is actually used in this test. This test takes typically about 30 minutes, and it is performed twice by the instrument to give you a series of curves. Each one of these can be viewed in greater detail if you visit our website.